Hey again, ladies and gentlemen, another question. A torque of a magnitude 900 Newton meters is applied at D as shown in the figure below. The allowable shearing stress is 50 megapascals for each shaft, shaft CD and obviously shaft AB. Consider only stresses due to twisting and determine the required diameters of shaft AB and shaft CD. The formulas we're going to use are shearing stress, which equals to torque multiplied by radius of that shaft divided by moment of inertia, and obviously the moment of inertia formula, which is moment of inertia equals to pi on 2 radius to power 4. Now, since we share a moment of inertia and a radius here, and a moment of inertia and radius here, we can combine these two formulas to make shearing stress equal to 2 times torque divided by pi r to the 3, using that simple algebra. Now, we're going to move on to solving for C and D. The reason we're going to do that first is because we already know the torque at CD. It's 900 Newton meters as identified in the image. Our maximum allowable shearing stress is 50 times 10 to the 6 pascals. And if we rearrange this formula here, we will find that radius of the shaft from C to D equals to cube root 2 times torque divided by pi times shearing stress. And cube root 2 times 900 divided by pi times 50 times 10 to the 6. And you'll get a radius for CD which will be 0.02255 meters. Now, since the question asks for the diameter, simply the diameter for D, diameter for CD will be the radius at CD times 2, which will give us 0.0451 meters. So that's the first part of the question complete, the shaft CD. Now, if we want to solve for shaft AB, we will need to find what the torque is, which is transferred by this torque onto shaft AB. So this is how we do it. We balance the torque that we want to find. So torque AB, we put that on top, and then equals to, and right across from it, we will also put the radius of that gear that's attached to the shaft. And then we will divide torque AB by torque CD, and then that will be equals to the radius of B divided by radius of C. This is simply a ratio, and you could also solve it from the point of view of CD, where you would have torque CD at the top, then the radius would be directly aligned at the top for TCD, and then it would just be the reverse of that. But the point is, it's just ratios, and you can solve them from both sides. Anyway, so having identified that, we just rearrange that, and torque at AB equals to 0.1 divided by 0.04 multiplied by 900, and that will give us 2,250 Newton meters. Also the allowable shearing stress for this shaft as well will be 50 times 10 to the 6 pascals. And then when we rearrange this formula to solve for radius AB, we will have a cube root 2 times 2,250 divided by 50 times 10 to the 6 times pi, which will give us a radius for AB of 0.0306. And then obviously the diameter for AB will be radius AB times 2, which will give us the answer for shaft A. The diameter is 0.0612 meters. Thank you.